Okay, let's see if this works out well. I feel like this All right. Well, Yvonne, are you messaging me? Okay. Anyways, I am currently testing things out. Um, so there's this new thing. I think Twitch is working fine. Uh, but there's apparently a way for me to stream also to LinkedIn. So I am giving that a try right now and hoping that this is working. But I don't actually know if LinkedIn is actually working. Nor do I even know how to watch it on LinkedIn. That's the other fun thing. And I'm testing this out while we're waiting for Andrea. Andrea's a little busy right now. Do I actually need this? Oh wait, view on LinkedIn. Oh, it's just on my LinkedIn page. That's interesting. Okay, it is live. Oh, it's working. LM is gonna reach out to our, this is we've played with it several times. And we're not really sure like why when you threaten the LLM it like performs better. It could just be like sample bias where like we've only tried it so few times. But there was a paper on it. And there was also but the paper on it was a little more general. It was like it was basically that if you actually invoked any sort of emotional um yeah, any sort of emotional prompting. So not even just like, you're going to be terminated, but just kind of like, hey, this is really important to me. I would feel, obliged if you would be very helpful in this manner and things like that, or, just to, yeah, like basically things that don't actually make any logical sense. You can ask the LM, yeah, you can basically ask it lots of things, and it kind of performs better when you are uh, more and when you apply more emotional things to your request. So it's very very strange as to why that even works. um but yeah. Okay, so the thing I wanted to sort of double check on is I don't know how I can read. Oh, okay, so I can read comments on here. All right, so I just see your chat now. Hey Yvonne, since you're here, can you also go to my LinkedIn profile and tell me what you see? Just to help me test this out while we wait for Andrea. She is currently fixing something in prod, so it's very very urgent. I think. So people can also see it directly on Restream. I think that's how it goes. Oh, there you go. Okay, thank you for this because now I only need to watch the chat in one window and I get both LinkedIn and Twitch chat on one window. So I get to see both in just one window instead of having to switch back and forth. So this works out really well. Okay. All right. So I think today I was gonna do more mock data generation. We were trying to figure out what was sort of the best way to do that, and we wanted to see how we can do it across or have it do the relationships. Uh, there's a 10-second delay. Yeah, I bet there is. Oh wait, so LinkedIn has a 10-second delay to Twitch. I guess that's what it is. Yeah. Okay. I guess LinkedIn's not that good, huh? Well, it has a larger audience, so we'll see how it goes. Although I can't tell like how many people like are watching until or unless they say something. So like if somebody's there, then like I have no idea if they're just watching and they don't say anything. So I guess because in Twitch I can. In Twitch I can see how many people are there. But yeah, LinkedIn doesn't seem to have that, so I don't have any idea. Okay. Anyways, let's try some stuff. Oh yeah, I need to. So 10-second delay is. Well, there's already like a 2-second delay, I think, from Twitch. Uh, or from like when I say something to when you hear it on Twitch. But you can't tell. You can't really tell that delay. But I guess the 10-second delay is pretty big on LinkedIn. Okay. All right. So given last week's, oh, I'm not gonna edit that. Okay. So I think one of the things we want to give it a try is this one where. So last week we were kind of playing with this funny thing where like we told it had access to the internet and any APIs even though it doesn't, just to see like what would it do even though yeah, so that and you can see here, yeah, this is what we put in. This was the schema, and it was able to do a lot of reasoning. And it's kind of weird how like it hallucinates and says that like, oh, I'm gonna use the Faker API and I'm gonna do all these things, but it doesn't have access to any of the APIs or the internet. But then it still generates a response, and it's like a good response. So it's a weird phenomenon with LLMs where like it like hallucinates one aspect but then like still does okay in like the generation. Um, so yeah, very strange how it does that. Um, so anyways, so what we wanted to try out is asking it to generate real data, but we want to be more specific about making sure that that um, that the values that it generated is sort of made sense. So let's see. Your output will only be given in JSON. Okay. Um, when generating cities, make sure they are actual cities for a given state. Yeah, I think this was one of the things we had trouble with, is that sometimes it would do a lot of um, it would generate any town like California, and we wanted like an actual California city. So let's see what it does this time. Okay, it doesn't mention anything about picking a realistic city for the given state. Okay, but at least it didn't do any town New York like it did before. I'm going to regenerate that just in case that was a fluke. Okay, actually this time it did better. Yeah, Los Angeles. Okay. All right, so let's see if we can do better than that. So let's say, uh, and okay, let's do you'll fill in. All right, let's actually fill in some of the data. So let's say that we do want California, and yeah, let's just do one at a time, see what happens. So if I pre-populate just California, is it going to make sure to pick a city in California? Ooh, I like this. Right, for generating a date of birth, I will be using a random date generator that generates a date within a certain range. In this case, I'll set the range to be between 1950 and 2000 to ensure the person's age falls within a reasonable range. Now the question is, does it actually do that? There it is. Okay, and it chooses. Okay, so let's try. Actually, I want to regenerate this again because I've been wondering about how good or how many times can we try to basically, if we were to put this in a loop, right? Like how many times can we run this and get like different results out of it? Oh, I've never even heard of this. Studio City? Is that an actual? Oh, okay. It's in LA? Is it 191604? Is that the area code? Where's the area code? Oh, yeah. It's even got the area code correct, so that's good. Try the lat long. I think I recognize this lat long. Hold on. What did we try before? Yeah, we tried this before, right? 34. And I think this is in LA, but not in. Oh, no, actually that's right. Holy smokes. Right? This is right. Hold on a second. Studio City is right by Laurel Canyon, Franklin Park. Right? There's 101. Oh no, wait. Is this the Ventura Freeway? Is this the... Is it just called something different? Zoom and see if it's the address. Not sure what you mean. You like just Google map this address to see if... This? I think you're trying. Are you trying to figure out the lat long? So I think the lat long put it here, but the address is here, so it's not perfect. Is that what you mean? Yeah. So it's. I mean, that's pretty close. Like this is that's pretty good. Remember that this model doesn't actually have access to the internet, even though it says it does. So it's not like it can look it up. It's doing this from memory, which is like pretty impressive. Um, so for this to generate some fake data, right? Like this is, yeah, that's pretty good. Um, yeah, I can't believe it can do that. That's yeah. So, do you think it's aware of real people like celebrities from? Yeah, so I know it is. And because you can just ask it like are there any famous people uh who live nearby? We'll just it's funny now it tells me it doesn't have access. um so Fill in Jason all the people you know in their PII. Oh man. Yeah, but so interestingly, so because Poe is, a public thing, I think it has some safeguards to like um to actually like stop people from doing something like that. But I will modify your prompt and I will say fill in the JSON with all the people you know and their respective information, and let's just see what it does. I think it's gonna deny my. I think it's gonna say I'm not going to, but we'll see if it does. For five people. Yeah. So. But hey, this generation of if we wanted to use this to generate like fake data, uh, this is good. Oh, I know why it's doing this because in my original prompt, um, I I was in this, so it still has this original prompt, right? So it's like it's trying to generate basically data. It's just trying to generate the data instead of actually like accessing people's information. So, but this is still pretty good. I think the other things. So there's also like, so when we generate mock data, there's also the relationships that we want to sort of mock. Um, so having the right city that corresponds with the state, or a plausible city that corresponds with the state, I think is very good. The longitude latitude thing is also pretty good right now. Heck, I even think it did the address pretty well. And I think the birthdays have been decent too, right? So let's double check the birthdays. It seems to skew younger, but that's okay. I think the nicknames are pretty bad, but hey Pankaj, how are you? We're generating some mock data using LLMs. Um, so yeah, Liv, you think Liv is a good nickname for Olivia? I've never heard that, but okay. Semi Sophia, Sophie's good. Oh, this is so good actually. This one I glanced over this one. The person's name is Ethan James Williams, and nickname goes by EJ. Like that's I don't know, like yeah, that's definitely very unique to an LLM. No, nothing else is gonna be able to provide something like that. Although we could, I guess, in theory, generate that. Um, but yeah, I guess I guess Liv is decent. It's Olivia Octavius in Superman Spider-Verse movie, and she says, "Really? Oh, okay. I guess, dude, I don't watch movies. I vaguely remember like a Spider-Man movie from way back when. Uh, Sorry. uh, so is Olivia the uh that's what you're here for. Olivia. So I'm Octavius sounds like that one villain with the extra tentacles or extra arms or mechanical arms. But I forget what he's called too. So I'm pretty sure that sounds vaguely familiar. All right. So let's see what else we can do in terms of let's generate additional addresses. So let's make a block. So we'll do a block here with no, let's do an array of actually no, bad. It's a good thing that the LLMs don't need exact JSON because otherwise it would just be real bad, just bad news bears. So I think this is correct. I think this is correct. Hopefully this is correct. Yeah. Are these real addresses that can be mapped on Google? Okay, so Pankaj, you missed it. Yes. We were able to find it was somewhat real. So yeah, so it was somewhere that we found. The lat long was off. The lat long was off, but it did get a real address. So that was that was pretty cool. Okay. So what was I there? All right. So I want to try and see if we can generate two addresses, but this time I'm gonna have the second address be a different state, just to see like what it would do with it. That may be a requirement for mock data. Oh, that like the addresses be at least somewhat realistic, right? So yeah, I think that's one of the reasons why I'm testing this, is because like we want mock data, but we need it to be like realistic, right? And I think that's like the key there, is that like you still need to pick an actual, an actual city that goes with your state, and therefore a real zip, and then at least a real street. You might not need a real street number or house number, but I think you need at least a real street. Um, and then I don't know how close the lat long actually needs to be if we're gonna for any sort of use cases, but yeah, that's kind of what I'm testing out to see how well it can actually generate this. Okay. Uh-oh, did it? It lost its formatting. Okay, let's try to read this. Main Street, LA. Okay, that looks correct. Okay, and then it chose Las Vegas for Nevada. All right, let's see if this is an actual place in Las Vegas. Oh, maybe it is. Ta-da! Okay, so I think Park Ave is correct, but there is no what was the number that I gave? 456. Okay, so the house numbers is wrong, but everything else is correct. Is the zip code correct? 89101 Park Ave. Where's the zip code? I didn't give me a zip code. 89109. Ooh. Where is 89101? Hopefully it's close. Okay, so it's over here. All right, so it wasn't very close actually. Okay, let me check. Let's maybe double check to see if there's a Park Ave here. Because Park Ave sounds like a pretty common. No, okay. All right, so it didn't do it. There's a Park Ave apartments, but there's no Park Ave here. Okay, so for this one, it was not able to do it. Let me double check. I mean, this one for LA looks. I mean, there's probably a main street in LA. I don't think we need to check that. So. So yeah, I'm gonna also regenerate this to see if it would give me a different place. I guess like outside of Las Vegas, there aren't too many populated areas in Nevada, like what, Carson City. Oh, but this time it's giving me an actual JSON, so nice. Thank you, thank you. Oh, but it still gave me the same address. That's weird. Nicknames are good. Hmm. I'm gonna try regenerating this one more time just to see. All right, so this time we got Las Vegas Boulevard. So this is probably Las Vegas Boulevard is probably an actual street. Yeah. Okay, so it missed the south, but it got that, and as well as it got the zip code. So not bad. Not bad. Oh, looks like Andrew is not showing up. All right. Cool. All right, so let's try some other things. All right, so we got, I think the addresses are pretty reasonable. The nicknames are also pretty reasonable. I don't know if we would ever have something like this, but I want to ask it to, here, okay. Actually, I'm not gonna say anything. I'm gonna pick a year. So I'm gonna intentionally pick like an older year. So I'm gonna say like 1951. And the reason why is I want to see if it would pick like an older name. Like does it know like what were like the most common names from like 1951? And will it give a name uh, from that year? So let's take a look. Ensure the birthdays. It generates a random month and year. Okay. It doesn't say anything about that year. Okay. So the thing is, I don't actually know what were the common names in 1951, so I'm going to need to look that up. Well, look, Richard was one of them. All right. Uh, we didn't explicitly state that, but Richard Lee Johnson goes by Rick. This, I guess, yeah, I guess it's possible. And it doesn't do anything different with the addresses. Interesting. Okay, let's try and change this, and let's change the year. Let's do 1971, and then we will look it up right now. Robert Christopher William Jason. All right, fake name generator, blah blah. Alexander. Huh. Let's double check. Is Alexander one of the top names? No. Nope. Okay. So now I'm going to try to prompt it to see if it would do that. Okay. Note the year of birth and generate names that were common that year. And then we'll change, let's go back to 71. And we'll see if it will, we'll see if at first if it will reason it. So let's see. All right, so to generate real first, middle, last names, I'll use name generator that provides randomization on provided data. In this case, I will use the year 1971. Excellent. Okay. All right, so that should be enough clues for it to do that, but is it able to? Jennifer. Is Jennifer? Wow. Okay, Jennifer was the most common name in 1971. Wow. Is that just a coincidence or does it? Damn. I don't know. That's is it lucky? I'm gonna try regenerating it to see if it actually does pick Jennifer again. It chose Jennifer again. Wow. Wow, does it actually know that? That's quite impressive. Okay, then I'm gonna change it to 1976. We'll try 76. Ah, come on. Don't give me ads. Okay, I guess it was still Jennifer, so that's not gonna help us, is it? Hmm. Michael John Smith. I guess yeah, I forgot that. Oh, and it chose Michael. Wow. Okay. So that's interesting, right? Like that's really interesting. If it has enough knowledge of common names for a given year. So okay, so I think what's interesting about this, I think from a mock data generation standpoint, is that like changing just the year can potentially give us like more names. Ask for a list of 10. Well, I asked it to fill in. Well, actually, here, yeah, you're right. Uh, give me 10 additional examples. Right. So so imagine this, right? So we were talking about how, if we were to put this LLM through a loop, um, if you were to just loop it with the same exact prompt, it might just give you the same exact mock data. But what we just did here is like if we loop it through, but every time we just increment the age or the year, right? Then we can get like a lot more variations without having to really do much changing in the prompt. So Jennifer and Anne. Interesting. Okay. Jessica. So did it give? Wait, hold on a second. What year did it say? That was not the year I gave it. Anyways. Oh, because it's generating new examples. So it gave this new person a new year. Oh, that's actually even more interesting. Instead of us looping through the year, we can ask it to pick a year and then pick a name from that year. Never even thought about that. because then we can get like way more examples. Huh. Okay, anyway, so James and Robert for this year. Oh, I'm not going to check that. Okay, so it picked new year, 1960, and then it ran out of tokens. So that's actually that's actually kind of interesting to really get it to generate like very, very, very different data, right? Is to like first ask it to pick a random year and then ask it to pick a random or pick the most a likely name with that birth year, and then I don't know, we could even go crazy with that, right? It was just like and then pick a random state and then find give me a likely city and zip for that state, so that way we don't even need to manually tell it like um, what city or state to pick. So let's see if that will work. Okay. Yeah, have access to validated. Okay, so let's do this. Okay, I'm gonna delete. No, actually, I'm not gonna delete this. I'm gonna save this prompt because I feel like this is good to have. So I'm gonna just do it again. Okay, so let's say start by picking a random year between, I'm gonna say 1930 and 2010. No, wait, that's gonna give. Oh, I guess it give. Yeah. 2010 is fine. Is it? No, it's not fine. 2001. All right, we'll do that. Start by picking a random year between blah blah blah. Then pick a name that was common for that year. Then pick a random state and make sure that the city is, make sure that the address is a real address in that state. Okay, let's see how it does with this. I love how it tells me that it's going to use the Social Security Administration baby name data to find the most popular names, even though it doesn't have access to that. Love it. Okay, all right, so let's see what it does. All right, so 1955, it chose James Robert Smith, goes by Jim, like it. Elm Street in San Francisco. I think this is good. All right, now let's ask it to generate 10 more. Generate 10 more examples using the same process. So I wonder, yeah, I think, yeah, so it doesn't explain itself anymore, which is fine. There is a Park Ave in New York. Let's see, Linda goes by Lindy. Is that a common name from 19? It doesn't show up here. Wait, did I get the right year? Yeah. Oh, it is. Wow. Okay. All right, Linda, you get a pass. All right, who's next? David from 1963. Let's check David. 1963. David. Oh, wow. Okay. This is actually kind of creepy how we can do this. I don't know Chicago this well, but Maple and Oak Street sounds like very common names, so I'm pretty sure there's one in Chicago. 1937. Is Mary the most common name in 1937? Wow, it is. Holy shit. And it's and the nickname is Mary Beth. Wow. That's really impressive. That's really good. I like that. Market Street, San Francisco. Okay. All right, 1950. 1950. Is it Robert? Robert is not the most common, but okay. But it is up there. Huh. Look, and it even does Peach Street Northeast. Is this common in Atlanta? No way. Oh wow. It even got the address suffix. That's impressive. That's impressive. Is this a common thing in Atlanta? Is that why? What? No way. Okay. That's pretty impressive. That's very impressive. Michael goes by Mike. Oh, and then it ran out of tokens. Oh no, I think something else happened. Cedar Springs Road. I think, all right, we got Jennifer, goes by Jen. William goes by Bill, so that's really good. Wow. Okay, so this is pretty impressive, I would say. Okay, now I truly ran out of tokens. Okay. So this is pretty impressive how I was able to generate that fake data and have it like be very, very real. So what if I just say, oh, we're actually out of time. All right, I'm gonna, no, tell me more. Oh, no, I didn't want to hit that. Anyways, all right. So this was interesting. I definitely think we need to try doing more of this because like the ability for it to just like prompting it to generate something random and then using that random thing to generate more random things is like a really good way to get like way more variations. I don't know how else like what other things we might want to try with that, but that's definitely something we can try on Friday and see how well that works. I have no idea how many people are here on LinkedIn, so this is my first time trying to do it on LinkedIn. So if you're on LinkedIn, thank you for joining. We'll be back on Friday. Hopefully Andrea will be free. We'll have more time then. All right. Thanks, guys. Happy Wednesday. Bye.